Hello everyone, this is Ahmed Imam teaching Advanced Machine Learning course. Especially in this course, we are going to focus more about the explainability and interpretability methods for machine learning and for artificial intelligence in general, mainly for computer vision. Sometimes we are going to use tabular data. Why are we interested in learning the decision-taking mechanism of a neural network or machine learning algorithm in general? Machine learning algorithms are going to control our rankings, and these rankings may control or may give us some opportunities or hinder some opportunities that we are need in a very bad way. So we are going to learn about explainable machine learning because we need to understand why the algorithm is taking this decision. Like as we have seen in this video, this lady is facing some injustice because one man can give you like a -1 ranking point, and it's taking in his consideration just the mental states that you are facing right now. But it doesn't take in his consideration another parameters like what did you have to this day, or what did you have on breakfast, or what did you eat this day, or how was your flight to the airport. He just see you in this specific point, but there is a lot of parameters controlling our behaviors. I think if this social credit system to be full justice, it needs to take everything in his consideration. Like for an example, like if I'm a lady, and if like I'm having like today I got like -1 point, and yesterday I got minus 0.5 points or something, the algorithm need to take in consideration everything, because maybe I'm facing injustice, I'm having like a defamation campaign or something. So the algorithm need to give like weighted average of these. If I'm getting a lot of negative rankings or negative ratings from a specific point, like I need to give less weight to this point because I understand like there is a defamation campaign coming from this place or something. Anyway, so we are learning and teaching explainable machine learning to be able at the end to give a reason for this lady who is facing injustice. In my point of view, we need to give her a reason, like why are you facing this injustice, why are you having like 3.2 and or 3.1 ratings, which is gonna give you like a hell of a life. You are not going to be able to get your flights, you are not going to be able to enter some specific places, some specific restaurants. You are not going to be able to take the metro or the train or something. So if she wants to appeal for this decision, we will be able to give her a reason, and we will be able to understand her needs. Maybe we can help her to get more justice and get her like 4.1 or 4.2 ratings again. But to be able to do that, we need to understand the decision taking mechanism of the algorithms that we have built, because most of these algorithms, most of these very complex nonlinear algorithms are not very clear why they are taking some decision, why not. To be able to understand that, we are going to teach in this course some of the famous interpretable or explainable methods, and hopefully I'm going to help you to understand this method or this explainability techniques. So this section or this tutorial, I'm going to just explain some of the vocabularies that you are going to face when you are reading any of the explainability books or any of the interpretability books that you can find in Amazon or something, or in your library. So mainly we are going to talk about what is the difference between interpretable machine learning models and explainable machine learning models. And then we are going to talk, or we're going to discuss the interpretability, and we are going to discuss what are the model agnostic methods. And those are the first things that we are going to talk about, like interpretability is an inherited property. So what are the interpretable models? Interpretable models, like for an example, decision tree is an interpretable model, linear regression is an interpretable model, logistic regression is an interpretable model. Why? Because like these models are very clear why it's taking the decision. To make a decision tree in order to give you a credit from a bank or something. So at the beginning, like I'm taking like a customer here. The customer, if the age of the customer is more than like 30 years, I'm going to let him in. If he's married, I'm going to give him a credit, like a higher credit. If he's not, I'm going to buzz him in the right direction. Like let's go here, yes and no. If he's married and he has kids, I'm going to get him here, and yes, and no here. If he has kids also, if they are income more than 50K per year, if yes, give him credit, give him his loan. If no, don't give him anything. I want to say, like, in these interpretable models, you can clearly see the nodes here. You can understand why the algorithm is taking his decision. So at the end, we are saying, we are naming these models interpretable models. Also, if you have a linear regression model and like we are having some points here, like if this age, like if we have like a 2D regression problem, here we are having age, and salary. We are trying to have a relation between age and salary to predict salary, for example, and we are having points here and here and here and here and here, and we are having some clustering points here which will influence. So because we are having lots of points in this place here, the line gonna pass through them here. So why the line is drawn between these points and not here, for example? Why we don't have the relationship here? It's not here. Why? Because we can say the reason behind this is we are having a lot of cluster points. We are having a cluster of points in this place and this place. So the relationship here can be explained, where we took this line to represent the relationship between seller and age, and why we didn't take the red line here. So at the end, if you can easily and clearly explain the decision-taking mechanism of the algorithm or the neural network, we can name this model, or we can name this algorithm, or an interpretable model. On the other hand, we are having explainable models. So explainable models, for example, are neural networks. Why? Because neural networks are mostly very deep, and we don't understand why are some filters are looking at these pixels and not looking at other pixels. So then we can say, like, if you can clearly and very easily explain the decision-taking mechanism of a model, you can name it explainable model. So this is a very simple comparison between explainable models, and on the left-hand side here, we can see that explainable models can be easily understood, and they have direct explanation for their decisions, and we can determine the cause behind the decision which is being taken. And interpretability is also an inherited property for the model. On the other hand, we can see that explainable models are the models which need effort to be understood, and it's not inherently explainable and clear. So we need to put effort, we need to integrate it with other methods to understand the decision-taking mechanism behind these models or behind these algorithms. So here we are going to talk about some vocabulary, which you can see in most of the interpretable machine learning books. You're gonna see a lot of local versus global explainability, and you're gonna see a lot of model agnostics or model specifics. And if you are going to read a paper about explainability or something, you're gonna see this vocabulary a lot. So in this first tutorial, I'm going to try to help you to understand like what's the meaning behind these. And also ad hoc and post hoc, yeah, it's very popular to see. Let's go and dive deep inside of these. Here we can see a comparison between both and what are the local explainability. For an example, activation maximization is a local explainability. Why? So if we are having a neural network here, and this is advanced machine learning course, so you need to understand at least what is the meaning of a neural network. So if you are having a neural network here, and this neural network in this specific point, like it has 3 neurons, and this is the final layer, and this is the output here. This is the output. If this neural network, for example, is trying to classify between 3 different classes, a cat, a dog, a car. So if the neural network sees that the image, the input was the cat, this is a cat with a probability of 0.7, and a dog with 0.1, and a car with 0.2. So there is an explainability method or something which is going to try to describe what are the specific pixels in the input image which are going to increase the score of a cat. Maybe it can add some scores from its point of view, maybe not, but in general, we are talking about local explainability methods. So if you are trying to explain something which is happening in a specific point in the model, not in the model in general, the name of this methods, the name of this group of methods is called local explanation. So if you're trying to explain the decision which is being taken in a specific layer or a specific neuron or a specific part of the neural network, group of methods called local explanation methods. So let's go back. An example of these methods is activation maximization, as I said, and you can read more about it if you are interested in it. Global explanations, we are trying to understand the general behavior of the neural network, not just a single layer or a single neuron. On the other hand, we are trying to understand the general behavior of all of the neuron and all of the filters and all of the layer at the same time. So, like an example for this, a permutation of feature method. So if we go back to the same neural network again here, and we are having the same neuron, this is the input here, and we are having a neural network here and an output here, and this is our network. That's very bad network, and this is output here. So, and we are having an input of a cat or something, and the output is saying that we are having a cat. We, in this global explanation methods, we are going to permute the input, or we're going to add some pixels or remove some pixels of the cat. And for example, maybe we can make some black pixel in the corner of the image and see if the output is being changed or not. And if it's changing, this means this corner here is very important for the neural network to take its decision. So we can make a moving box algorithm to go around the input image and see which part or which corner of the image is being very important for the algorithm to take its decision. So these type of methods are called global explanation methods, and in this method we are trying to understand the general behavior of the method. So another comparison between two vocabularies that you're gonna see in most of the books are model agnostic and model specific methods. I think my notebook here is not very perfect. Alright, so yeah, we are having another comparison between model agnostics and model specifics. So what's the meaning of model agnostics methods and model specific methods? So I think this model specific here. Model specific methods is a specific group of explainability methods which can use only with a single group of algorithms. For example, Shapley methods. Shapley methods can be used only with neural networks. For this, yeah. So Shapley is used better with neural network, and it can describe in a sort of the decision-taking mechanism of a neural network. On the other hand, there are some model agnostics methods. And what's the meaning of this? That there are explainability methods which can be used on different types of models and different type of algorithms. Alright, so let's go to another vocabulary here, another comparison between ad hoc and post hoc. Ad hoc is the model is originally built to be interpretable, and an example for this is a decision tree. So let's go to another comparison between ad hoc and post hoc. You're gonna see this a lot. So if you are having an ad hoc explanation method, this means that the model is originally built to be interpretable, and you don't need to put a lot of efforts to explain its decision because it's already built to be explainable. An example for this is decision tree, as we have seen before, and also linear regression and logistic regression. And post hoc is a group of methods which is being used after the model being trained. So most of the methods that we have seen in the explainable methods are also post hoc methods, because we are integrating some external methods, or we're integrating some external algorithms to our original algorithm to be able to understand its decision-taking mechanism. Another comparison here, it's between data modality agnostics and data modality specifics. And the meaning behind this, like there are some models, there are some explanation methods, which is being only used with, as an example, with images. And there are another group which is being only used with tabular data. So this is also like a type of comparison or type of grouping of explanation methods. That was it for today. You can read more about the taxonomy of explainability in machine learning. You're going to see these vocabulary in a lot of literature. So I hope I could be helpful for you to understand this in a very high level way. If you are interested in a specific vocabulary and a specific taxonomy, you can read more about it in the literature. So that was it for today, and thank you.